Hello there, and welcome to the Slumber Lab, where curiosity meets comfort and science drifts gently into dreams. Tonight, we're embarking on a peaceful journey through one of humanity's most ancient and spectacular traditions, fireworks. We'll explore the chemistry that paints the sky, the history that spans millennia, and the quiet science behind those brilliant bursts of light and colour. Before we begin our gentle exploration, I'd love to know where in the world you're listening from and what time it is in your corner of the night. There's something rather fitting about discussing fireworks across different time zones, each of us experiencing this moment under our own patch of sky. If you find this journey soothing or perhaps surprisingly fascinating, I'd be ever so grateful if you gave the video a like and maybe subscribed. It helps this little corner of calm science reach others who might need a peaceful pause in their day. Now, I do hope this isn't so captivating that it keeps you awake. But if it does, well, at least you'll drift off knowing something wonderful about the art and science of lighting up the darkness. So settle in, take a deep breath, and let's begin our quiet voyage into the brilliant world of fireworks. Fireworks are really quite remarkable. When you think about it, they're essentially controlled explosions designed not to destroy, but to delight. Tiny packages of chemistry launched into the night sky to bloom into flowers of light, each burst a carefully orchestrated dance of physics and artistry. But what exactly is a firework? At its heart, it's a delivery system for beauty, a small container packed with precisely measured chemicals that, when ignited, transform into cascades of color and light. It's alchemy made visible, the transformation of simple elements into pure wonder. The basic anatomy of a firework is elegantly simple, yet ingeniously complex. There's the shell, usually made of cardboard or paper, that holds everything together. Inside, you'll find the lift charge, which propels the firework skyward, and the burst charge that creates the explosion itself. But the real magic lies in the stars, small pellets of chemical compounds that create the colors and effects we see. Each star is like a tiny paint pot waiting to be opened, containing metal salts that, when heated, emit specific wavelengths of light. This is the same principle behind those chemistry lab flame tests you might remember, where different elements burn with characteristic colors. In fireworks, this science becomes art. The journey of a firework begins in the mortar, a tall tube that acts as a launch pad. When the fuse is lit, it ignites the lift charge, creating a small explosion that shoots the shell hundreds of feet into the air. Meanwhile, a time fuse burns slowly, calculating the perfect moment for the grand finale. When the shell reaches its peak, the burst charge detonates, scattering the stars in all directions. As these stars streak through the air, they burn brightly, each one a tiny meteor painting, trails of color against the darkness. The patterns they create, chrysanthemums, willows, peonies, are determined by how the stars are arranged inside the shell. It's three-dimensional choreography planned on the ground and performed in the sky. But fireworks aren't just about visual spectacle. They engage all our senses. The thunderous boom that follows each burst, the faint smell of sulfur and smoke drifting on the night breeze, the way the light reflects off faces in the crowd below. There's something primal about our response to fireworks, perhaps because fire has always meant safety, warmth, and community to our species. The science behind fireworks touches on chemistry, physics, and even a bit of psychology. The rapid combustion creates not just light, but sound waves that travel through the air, reaching our ears moments after our eyes have already drunk in the display. This delay between flash and boom is a gentle reminder of the distances involved and the finite speed of sound. Each firework is also a small lesson in Newton's laws of motion. The force that propels the shell upward creates an equal and opposite reaction, pushing down on the mortar. The explosion that scatters the stars follows the principle that energy can neither be created nor destroyed, only transformed from chemical potential energy stored in the compounds to kinetic energy in the moving stars, to light, heat, and sound. Even the colors themselves tell a story of atomic physics. When the metal salts are heated, their electrons become excited, jumping to higher energy levels. But like all things in nature, they seek stability, and as the electrons fall back to their ground state, they release that excess energy as photons of light, each element releasing its own unique signature of color. Strontium gives us deep reds, sodium produces brilliant yellows, copper creates those stunning blues and greens, barium provides pale greens, and magnesium and aluminum add the brilliant whites that outline and accent the other colors. It's the periodic table painted across the night sky, each element contributing its voice to the celestial symphony. There's something deeply satisfying about understanding the science behind beauty. It doesn't diminish the wonder, it enhances it. To know that those cascading golden willows are actually burning iron filings, or that the brilliant blue chrysanthemums come from copper compounds, adds layers of appreciation, like knowing the brushstrokes that created a masterpiece. The timing of everything is crucial too. The fuse must burn at exactly the right rate to ensure the shell explodes at its peak altitude. Too early, and the effect is lost in the brightness of the ground. Too late, and gravity begins to scatter the stars before they can paint their full picture. It's a delicate balance of chemistry and physics, orchestrated by pyrotechnicians who are part scientist, part artist. Modern fireworks can achieve effects that would seem like magic to their ancient inventors. Stars that change color mid-flight, shells that burst into perfect geometric patterns, effects that seem to hang in the air defying gravity. These innovations come from decades of experimentation with new chemical formulations and mechanical designs. Yet for all the technical sophistication, the basic appeal of fireworks remains unchanged. They represent our desire to celebrate, to mark important moments with something extraordinary. They're temporary art that exists only in the moment, shared experiences that bring communities together under the same sky. There's also something wonderfully democratic about fireworks. They can be appreciated by anyone, regardless of age, education, or background. A child watching their first fireworks display experiences the same fundamental awe as someone who has seen thousands. The science may be complex, but the emotional response is immediate and universal. As we drift into the history and development of these magical devices, remember that every firework you've ever seen represents centuries of human curiosity and creativity. The desire to take simple, earthly materials and transform them into something that lights up the heavens. It's science in service of joy, chemistry dedicated to celebration. The story of fireworks begins not with celebration, but with serendipity in ancient China, nearly 2,000 years ago, where alchemists searching for the elixir of life instead discovered something that would forever change how humanity marks its most joyous occasions. Picture this. Around 200 BC, someone tossed bamboo stalks into a fire, perhaps seeking warmth on a cold night. The hollow stalks filled with air, heated rapidly until they exploded with sharp cracks that echoed through the darkness. The Chinese called this baozhu, which means exploding bamboo, and believed the loud sounds could frighten away evil spirits and bad luck. For over 1,000 years, this simple tradition continued. People would roast bamboo stalks during festivals and celebrations, letting the natural explosions mark important moments. But human curiosity rarely stays satisfied with the status quo, and in the background, Chinese alchemists were conducting their own experiments. These early scientists weren't trying to create fireworks. They were on a much grander quest, seeking the secret to eternal life. Mixing various substances in their laboratories, hoping to discover the Philosopher's Stone or the elixir of immortality. One of their most promising leads involved combining saltpeter, sulfur, and charcoal, ingredients that seemed to hold mysterious properties. What they discovered instead was a mixture that exploded with far more force than bamboo could ever produce. This accidental invention of gunpowder sometime during the Han Dynasty was perhaps one of history's most significant mistakes. These alchemists, seeking to extend life, had instead created the foundation for both warfare and celebration. But the Chinese, being remarkably practical people, quickly found uses for this new discovery. They packed the explosive mixture into bamboo tubes, creating the world's first firecrackers. These early fireworks served the same purpose as the original bamboo explosions, driving away evil spirits, but with much more impressive results. The credit for developing these early fireworks often goes to a Chinese monk named Li Tan, who lived in Hunan province near the city of Liuyang. Li Tan is remembered as the inventor of what we would recognize as a proper firecracker, and every April 18th the Chinese still honor his memory with celebrations and offerings. Liuyang, the city near Li Tan's home, became the center of fireworks production, and remarkably, it remains so today. This region still produces the vast majority of the world's fireworks nearly 1,500 years later. It's a testament to how deeply fireworks became embedded in Chinese culture. During the Song dynasty, fireworks evolved from simple noisemakers into genuine entertainment. By the year 1100, common people could purchase various types of fireworks from market vendors, and elaborate displays were mounted for imperial celebrations. Emperor Huizong was treated to grand military fireworks displays that must have seemed like magic to medieval audiences. These early fireworks weren't just about loud bangs. The Chinese developed rockets called earth rats that skittered along the ground, shooting sparks and creating chaos and delight in equal measure. They created aerial shells that burst in the sky, and various ground effects that painted the night with fire and light. One historical account from 1264 tells of an early rocket that went off unexpectedly near Empress Dowager Gongsheng during a feast, startling her considerably. This incident gives us a glimpse into how fireworks were becoming part of court entertainment. Elaborate displays that could occasionally go hilariously wrong. The Chinese also developed the first aerial fireworks shells that burst high above the ground, creating the familiar blooming effects we associate with modern displays. These innovations required sophisticated understanding of timing, fuses, and explosive charges. Knowledge that was carefully guarded and passed down through generations of pyrotechnicians. But fireworks in China weren't just entertainment. They were deeply woven into the cultural and spiritual life of the people. Different colors and effects were believed to carry different meanings. Red for good fortune, gold for prosperity, white for purity. These weren't arbitrary associations, but reflected deep beliefs about the connection between earthly celebrations and cosmic harmony. The production of fireworks became a respected craft, with master artisans developing secret formulations and techniques. Workshops in Luoyang and other centers buzzed with activity as craftsmen mixed chemicals, rolled papers, and assembled the intricate mechanisms that would carry their art into the sky. By the time Marco Polo arrived in China in the 13th century, fireworks had become an integral part of Chinese culture. The Italian explorer witnessed displays that he described as unlike anything in Europe, where celebrations were limited to bonfires and simple torches. The sophistication of Chinese pyrotechnics must have seemed almost supernatural. The Chinese had also begun to understand the science behind their art. They knew that different mixtures produced different effects, that the size and shape of containers influenced the patterns created, and that timing was everything. They developed increasingly complex shells with multiple chambers, creating sequential effects and color changes. These early fireworks also played important roles in Chinese military strategy, where the same principles that created beautiful displays could be weaponized. The knowledge of explosives and projectiles that developed alongside celebratory fireworks contributed to Chinese military innovations that would eventually spread across the world. Religious and philosophical elements were deeply embedded in Chinese fireworks traditions. The explosions were thought to carry prayers skyward. The bright lights symbolized the connection between earth and heaven, and the temporary nature of the displays reflected Buddhist and Taoist teachings about the impermanence of all things. As dynasties rose and fell, fireworks remained a constant in Chinese culture, adapting to new rulers and new occasions, but always maintaining their essential purpose, bringing light to darkness, marking important moments, and creating shared experiences that bound communities together. The workshops of ancient China were filled with the careful work of measuring and mixing, grinding and rolling, each firecracker and shell a small miracle of chemistry and craftsmanship. The knowledge passed from master to apprentice in an unbroken chain that stretches from those first bamboo explosions to the spectacular displays we see today. When we light fireworks today, we're participating in a tradition that spans 2 millennia, connecting us to those ancient Chinese alchemists who sought immortality and instead gave humanity something perhaps even more precious: the ability to paint the night sky with joy. The journey of fireworks from ancient China to the rest of the world is a tale of wonder, spreading along trade routes carried by merchants, explorers, and adventurers who witnessed these magical displays and simply had to share them with their homelands. The most famous messenger in this story is Marco Polo, the Venetian explorer whose travels to China in the 13th century introduced him to wonders beyond European imagination. Among the silk, spices, and other marvels he encountered, fireworks must have seemed like captured lightning, controlled magic that defied everything Europeans understood about fire and celebration. When Marco Polo returned to Venice around 1295, he brought with him not just goods, but knowledge, including the secrets of gunpowder and its celebratory applications. However, the transition from Chinese fireworks to European ones wasn't immediate. The knowledge had to be adapted to local materials, customs, and capabilities. Early European attempts at fireworks were crude compared to their Chinese ancestors, but they served their purpose. Italian city-states began incorporating fireworks into religious festivals and civic celebrations. These early displays were simple affairs, mostly ground-based fountains and wheels that spun and threw sparks, but they represented the beginning of a new tradition. By the 14th century, fireworks had spread throughout Europe, appearing in England, France, Germany, and beyond. Each culture adapted the technology to its own needs and celebrations. The knowledge spread through trade networks, carried by merchants who had witnessed displays in distant lands, and by scholars who studied the principles behind these explosive wonders. The royal courts of Europe quickly embraced fireworks as symbols of power and magnificence. Elaborate displays became ways for monarchs to demonstrate their wealth and sophistication to subjects and rival rulers. Henry VII of England is credited with the first royal fireworks display on his wedding day in 1486, setting a precedent that would continue for centuries. These royal displays grew increasingly elaborate as European pyrotechnicians developed their skills. James II's coronation fireworks in 1685 were so impressive that the firemaster responsible was knighted by the king, a not bad reward for expertise in controlled explosions. Peter the Great of Russia took things even further with a 5-hour fireworks display to celebrate the birth of his son. European innovations began to distinguish themselves from Chinese traditions. While the Chinese had focused on meaning and symbolism, Europeans became obsessed with scale and spectacle. They developed larger shells, more powerful charges, and increasingly complex mechanical devices that created elaborate ground effects. The development of fireworks in Europe also coincided with advances in chemistry and metallurgy. European alchemists and early chemists began experimenting with different formulations, seeking to improve the brightness, duration, and effects of their displays. These innovations would eventually lead to the colorful fireworks we know today. Jesuit missionaries played an important role in the technical development of fireworks, serving as conduits between Chinese knowledge and European innovation. Pierre-Nicolas Le Chéron d'Ancarville, living in Beijing in the 18th century, wrote detailed accounts of Chinese fireworks methods to the Paris Academy of Sciences, helping to spread technical knowledge throughout the scholarly community. The French were particularly enthusiastic adopters of fireworks technology. Amédée François Fraisier published his treatise on fireworks in 1747, one of the first comprehensive European works on the subject. His book covered not just the technical aspects, but also the artistic principles behind creating effective displays. Handel's music for the royal fireworks, composed in 1749 to celebrate the peace treaty of Aix-la-Chapelle, demonstrates how deeply fireworks had become embedded in European culture. The fact that one of the greatest composers of the age wrote music specifically for a fireworks display shows how these events had evolved from simple entertainment to high art. But the spread of fireworks wasn't limited to Europe. Arab traders and travelers also encountered Chinese fireworks and brought the knowledge to the Middle East and North Africa, where they were adapted to local traditions and celebrations. The Ottoman Empire became particularly renowned for its elaborate fireworks displays, which combined Chinese techniques with Islamic artistic sensibilities. The knowledge also spread eastward through Asia, reaching Japan, Korea, and Southeast Asia, each culture adding its own innovations and artistic interpretations. The Japanese developed particularly sophisticated techniques for creating delicate effects that matched their aesthetic preferences, while Korean pyrotechnicians became known for their precision and timing. As fireworks spread, they began to influence local traditions and celebrations in ways that went far beyond simple entertainment. They became part of religious festivals, harvest celebrations, and royal ceremonies, each culture finding ways to incorporate these magical displays into their most important occasions. The technical knowledge also evolved as it spread. European metallurgy contributed to stronger shells and more reliable fuses. Islamic mathematics influenced the calculations of trajectories and timing. Various cultures contributed new chemical combinations that expanded the range of effects possible. By the 16th century, fireworks had become a truly global phenomenon, with distinct regional styles and traditions. Chinese fireworks retained their emphasis on symbolism and meaning. European displays focused on grandeur and spectacle. Middle Eastern fireworks incorporated geometric patterns and mathematical precision. Various Asian cultures developed their own unique approaches. The spread of fireworks also created the first international trade in what we might call entertainment technology. Chinese craftsmen found markets for their products throughout Asia, while European innovations spread back to China, creating a cross-pollination of ideas that benefited pyrotechnicians everywhere. Missionary accounts and diplomatic reports from this period are filled with descriptions of fireworks displays that amazed visitors from other cultures. Lev Ismailov, Peter the Great's ambassador to China, reported that Chinese fireworks were unlike anything anyone in Europe had ever seen, while Chinese visitors to European courts were equally impressed by the scale and mechanical complexity of Western displays. This cultural exchange wasn't just about technique, it was about philosophy and meaning. Different cultures brought different ideas about what fireworks should represent and accomplish. The Chinese emphasis on harmony and balance influenced European thinking, while European ideas about dramatic climax and grand finale found their way into Asian displays. The global spread of fireworks also created new challenges and opportunities. European demand for Chinese fireworks led to expanded production and trade, while local manufacturers in various countries began developing their own capabilities. leading to innovations and improvements that benefited the art worldwide. As we follow this trail of sparks and wonder across continents and centuries, we see how a single invention can capture human imagination so completely that it spreads across every barrier of a language, culture, and geography. Fireworks became a universal language of celebration, one that transcends borders and brings joy to people everywhere. When fireworks first arrived in the American colonies, they came not as foreign curiosities, but as familiar celebrations of liberty and independence. The year 1777 marked the first anniversary of American independence, and it was celebrated with fireworks displays that would establish a tradition lasting more than 2 centuries. The Founding Fathers embraced fireworks as symbols of the new nation's spirit. John Adams, in a letter to his wife Abigail, predicted that Independence Day would be celebrated by succeeding generations with bonfires and illuminations from one end of the continent to the other. His prediction proved remarkably accurate. Early American fireworks were largely imported from China or created by craftsmen who had learned their trade in Europe. But as the nation grew, so did its capacity for creating its own celebrations. American pyrotechnicians began developing techniques and styles that reflected the character of their young country. The 4th of July became the premier fireworks holiday in America, but celebrations weren't limited to Independence Day. Political victories, military triumphs, and civic occasions all provided excuses for lighting up the sky. American communities took pride in their fireworks displays, competing to create the most impressive shows. By the 19th century, American fireworks had developed their own character, emphasizing spectacular aerial effects and patriotic themes. Red, white, and blue became the standard colors for Independence Day displays, while other occasions called for different color schemes and effects. The Industrial Revolution transformed American fireworks production, just as it changed every other aspect of manufacturing. Improved chemistry, better materials, and more efficient production methods made fireworks more affordable and more widely available. What had once been luxury entertainment for the wealthy became accessible to ordinary communities. American innovation also contributed to fireworks technology. The development of new chemical formulations, better fusing systems, and more reliable ignition methods came from American workshops and laboratories. These innovations were shared globally, contributing to improvements in fireworks everywhere. The Civil War period saw both a temporary decline in civilian fireworks, as resources were diverted to military purposes, and new innovations in explosive technology that would later benefit the fireworks industry. The knowledge gained from military applications of explosives contributed to safer and more effective fireworks. As America urbanized, fireworks displays became community events that brought neighborhoods together. The tradition of public displays funded by local governments or civic organizations created shared experiences that helped build community identity. These weren't just entertainment. They were expressions of civic pride and national identity. The late 19th and early 20th centuries saw the rise of professional fireworks companies in America. Firms like the Pyrotechnic Arts Company and others began creating elaborate displays for major celebrations. These companies employed skilled pyrotechnicians who elevated fireworks from simple entertainment to sophisticated art. American fireworks also began incorporating new technologies. Electric ignition systems allowed for more precise timing and safer operation, while improved transportation networks made it possible to stage elaborate displays in locations far from manufacturing centers. The story of fireworks begins not with celebration, but with curiosity. In ancient China, around 2,000 years ago, alchemists were engaged in a noble pursuit that would seem almost comically misguided today. They were searching for the elixir of life, a magical potion that would grant immortality. These early scientists, working with primitive equipment and boundless imagination, mixed together various substances in their quest to unlock the secrets of eternal youth. Among their experiments was a peculiar combination of ingredients: saltpeter, which we now know as potassium nitrate, sulfur, and charcoal. When heated, this mixture didn't grant eternal life as hoped, but it did something far more dramatic. It exploded. This accidental discovery, occurring sometime during the Han Dynasty between 206 and 220 BC, would eventually reshape human civilization in ways those ancient alchemists could never have imagined. But the path from accidental explosion to celebratory spectacle wasn't immediate. The Chinese, being practical people, first noticed that these explosive mixtures created tremendous noise when ignited. And noise, they believed, had a very specific and important purpose. It could frighten away evil spirits. This belief led to the creation of the first primitive fireworks. Though they bore little resemblance to the colorful displays we know today, the earliest versions were remarkably simple. The Chinese would take bamboo stalks, hollow them out, and pack them with their newly discovered explosive mixture. When thrown into a fire, these bamboo tubes would explode with a tremendous crack, sending sparks and flames shooting into the darkness. The word baoju, which means exploding bamboo in Mandarin, reflects this humble beginning. These weren't yet the soaring, bursting displays of modern fireworks, but rather loud, startling bursts designed more for spiritual protection than entertainment. The transition from spiritual tool to celebratory spectacle happened gradually. During the Song dynasty, which lasted from 960 to 1279, fireworks began to evolve into something closer to what we recognize today. It was during this period that a Chinese monk named Li Tian, living in Hunan province near the city of Liuyang, is credited with creating what we might consider the first true firecracker. His innovations were so significant that the Chinese people built a temple in his honor, and to this day, April 18th is celebrated as a day to honor his contribution to the art of pyrotechnics. What makes Li Tian's story particularly remarkable is how his work transformed not just the technology of fireworks, but their cultural significance. Under his influence, fireworks began to move beyond simple noisemakers into more sophisticated devices capable of creating visual spectacles. The region around Liuyang, where Li Tian lived and worked, remains to this day the largest producer of fireworks anywhere in the world, a testament to the enduring legacy of his innovations. By the Song dynasty, fireworks had become sophisticated enough that common people could purchase them from market vendors. Historical records tell us of grand displays mounted for imperial entertainment. In 1110, a massive fireworks show was held to entertain Emperor Huizong, demonstrating that these explosive spectacles had moved from the realm of spiritual protection into the world of royal entertainment. These weren't just random explosions, but carefully choreographed displays designed to inspire awe and wonder. During a feast held in honor of Empress Dowager Gongsheng, one of these devices accidentally went off near her, startling the royal party. While this might have been embarrassing for the pyrotechnicians involved, it represents one of the earliest recorded examples of rocket propulsion, a principle that would eventually help humans reach the stars. The evolution of fireworks during these early centuries reflects something profound about human nature: our irrepressible desire to transform the practical into the beautiful, the mundane into the magical. What began as a failed alchemical experiment became a tool for spiritual protection, which in turn became a source of entertainment and wonder. This transformation speaks to the creative spirit that drives all scientific and artistic endeavor. As these early fireworks developed, so too did the understanding of the forces that made them work. Ancient Chinese pyrotechnicians, working without modern chemistry or physics, nevertheless developed an intuitive understanding of combustion, pressure, and timing. They learned to control the speed of burning by adjusting the composition of their powder. They discovered how to create different effects by changing the shape and size of their containers. They developed techniques for launching projectiles into the air and controlling when and how they would explode. This accumulated knowledge represented centuries of careful observation, experimentation, and refinement. Each generation of firework makers built upon the discoveries of those who came before, gradually pushing the boundaries of what was possible. The craft became a form of applied science, requiring not just artistic vision, but also deep technical knowledge. The social and cultural impact of these early fireworks extended far beyond entertainment. They became integral to Chinese festivals and celebrations, marking important occasions with displays of light and sound that brought communities together. The technology also had military applications, as the same principles that created beautiful displays could be adapted to create weapons of war. This dual nature of fireworks, as both destroyer and celebrant, reflects the complex relationship between human creativity and the forces we unleash. What's particularly striking about this early period is how the development of fireworks required collaboration between different types of knowledge. Alchemists provided the chemical understanding, craftsmen contributed manufacturing techniques, artists supplied aesthetic vision, and military engineers added practical applications. This interdisciplinary approach would become a hallmark of fireworks development throughout history. The Chinese mastery of fireworks technology gave them a significant advantage in both celebration and warfare for many centuries. The knowledge was carefully guarded, passed down through families and guilds, creating a tradition of expertise that would eventually spread across the world. But for now, in these early centuries, fireworks remained primarily a Chinese art, a beautiful expression of their culture's unique blend of scientific inquiry, artistic sensibility, and spiritual belief. As we consider these ancient origins, it's worth reflecting on the remarkable chain of events that led from a failed immortality experiment to the spectacular displays that light up our skies today. Those early alchemists, disappointed by their inability to create eternal life, could never have imagined that their accidental discovery would bring joy to countless millions of people across the centuries. As we've traced fireworks through their ancient origins and scientific foundations, we've seen how these brilliant displays evolved from simple bamboo explosions to the sophisticated pyrotechnic artistry we know today. But the story of fireworks is far from complete. The chemistry that creates their colors, the physics that shapes their explosions, and the innovations that continue to push the boundaries of what's possible in the night sky represent not just entertainment, but a fascinating intersection of science, art, and human ingenuity. Let's turn our attention now to the heart of what makes fireworks truly captivating: the mesmerizing colors that paint the darkness and the intricate science behind each brilliant hue. When you watch a firework burst overhead, you're witnessing one of chemistry's most elegant demonstrations, where the precise arrangement of metallic salts and chemical compounds creates a palette that would make any artist envious. Yet behind each fleeting moment of color lies a complex dance of electrons, energy levels, and electromagnetic radiation that transforms simple elements into spectacular light. The science of firework colors begins with a fundamental principle of chemistry. When certain metals are heated to extreme temperatures, their electrons become excited and jump to higher energy levels. As these electrons inevitably fall back to their ground state, they release energy in the form of photons, particles of light that carry specific wavelengths corresponding to distinct colors. This phenomenon, known as atomic emission, is the same principle behind neon signs, street lamps, and even the aurora borealis. But in fireworks, it's harnessed with artistic precision to create controlled bursts of brilliant color. Different metals produce characteristically different colors when heated, creating what pyrotechnicians call the firework color palette. Strontium compounds, for instance, produce the deep crimsons and scarlets that dominate patriotic displays, when strontium nitrate or strontium carbonate burns at temperatures exceeding 1000 degrees Celsius, the metal's electrons emit photons with wavelengths around 650 to 700 nanometers, perfectly positioned in the red portion of the visible spectrum. The intensity and purity of this red light is so reliable that strontium has become the gold standard for red fireworks worldwide. Copper, meanwhile, creates the brilliant blues that often serve as the centerpiece of elaborate displays. Copper chloride, when heated, produces an intense blue-green light with wavelengths around 450 to 500 nanometers. However, achieving a pure, deep blue in fireworks remains one of pyrotechnics' greatest challenges. Blue flames require extremely high temperatures to maintain their color intensity, and any contamination from other metals, particularly sodium, can shift the color toward green or white. This is why blue fireworks are often more expensive and technically demanding to produce than other colors. Sodium creates the brilliant yellows and golds that add warmth to firework displays. Sodium compounds burn with such intensity that even tiny amounts can overwhelm other colors, producing bright yellow light at wavelengths around 589 nanometers. This is the same wavelength produced by sodium street lamps, which is why they cast that characteristic yellow glow. In fireworks, sodium's dominance means that pyrotechnicians must be extremely careful to prevent cross-contamination between different color formulations. Barium compounds produce the greens that often complement red and blue in elaborate displays. Barium chloride or barium nitrate, when heated, emits light primarily at wavelengths around 515 to 520 nanometers, creating colors ranging from pale yellow-green to deep emerald. The intensity of barium's green light makes it particularly effective for creating vivid, eye-catching effects that can be seen from great distances. For white and silver effects, pyrotechnicians turn to magnesium and aluminum. These metals burn with such intensity that they produce light across the entire visible spectrum, creating brilliant white light that often serves as the backbone of complex multicolor displays. Magnesium, in particular, burns so brightly that it can briefly outshine even the moon, making it perfect for creating those spectacular silver waterfalls and brilliant white bursts that punctuate many firework shows. Creating more exotic colors requires increasingly sophisticated chemistry. Orange effects typically come from calcium compounds, which emit light at wavelengths around 620 nanometers. Purple, one of the most challenging colors to achieve, usually requires a careful mixture of strontium for red and copper for blue, balanced in precise proportions to create the desired hue. The difficulty lies in ensuring that both metals burn at the same temperature and rate, preventing one color from dominating the other. The chemistry becomes even more complex when pyrotechnicians attempt to create color-changing effects or multiple colors within a single firework. These effects often rely on layered compositions, where different metal salts are arranged in specific patterns within the firework shell. As the explosion progresses, different layers ignite in sequence, creating transitions from one color to another or simultaneous displays of multiple hues. Temperature control is crucial for maintaining color purity and intensity. Each metal requires specific temperature ranges to produce its characteristic color, and variations in temperature can significantly alter the final result. Too low, and colors appear dim or shift toward undesired hues. Too high, and the intense heat can wash out colors entirely, producing only white light. Pyrotechnicians must carefully balance fuel compositions, oxidizers, and burning rates to maintain optimal temperatures throughout the entire burn time. The oxidizers used in firework compositions also play a critical role in color production. Potassium perchlorate is favored for many color formulations because it burns cleanly and provides sufficient oxygen for complete combustion without introducing additional colors. Potassium nitrate, while cheaper, can sometimes produce a slight yellow tint that affects color purity, Strontium nitrate serves a dual purpose, acting both as an oxidizer and as the source of red color. Modern pyrotechnicians have also developed techniques for enhancing color saturation and creating special effects. Chlorine donors, such as polyvinyl chloride or hexachloroethane, can intensify certain colors, particularly blues and greens, by helping to form metal chlorides that burn with more vivid hues. However, these additives must be used sparingly, as too much chlorine can create environmental concerns and affect the stability of the composition. The physics of light emission in fireworks also explains why some colors appear more vivid than others to the human eye. Our eyes are most sensitive to green light, which falls in the middle of the visible spectrum, making green fireworks appear particularly bright and intense. Red and blue, at the extremes of visible light, require higher intensities to appear equally vivid, which is one reason why achieving brilliant reds and blues remains technically challenging. Environmental considerations have also influenced modern color chemistry. Traditional formulations often relied on toxic metals like lead and mercury for certain effects, but contemporary pyrotechnicians have developed safer alternatives using more environmentally friendly compounds. Research continues into biodegradable color agents and reduced smoke formulations that maintain the visual impact while minimizing environmental impact. The artistry of firework colors extends beyond simple hues to include effects like strobing, where colors pulse on and off, and color-changing displays where single fireworks transition through multiple colors during their burn. These effects require precise timing and chemical engineering, with different components designed to ignite and burn out in carefully orchestrated sequences. Understanding firework colors reveals the elegant marriage of chemistry and artistry that defines pyrotechnics. Each burst of color represents countless hours of research, testing, and refinement, where chemists and artists work together to transform basic elements into moments of wonder. Building on the scientific journey we've traced through the ancient origins and evolving chemistry of fireworks, we now find ourselves at a fascinating crossroads where tradition meets innovation. The art of pyrotechnics, which began with Chinese alchemists seeking immortality and evolved through European royal spectacles to American celebrations of independence, continues to transform in remarkable ways. Today's fireworks industry represents a captivating blend of time-honored craftsmanship and cutting-edge technology, where the fundamental chemistry discovered centuries ago merges with modern engineering, environmental consciousness, and digital precision. The contemporary fireworks landscape tells a story of adaptation and advancement that would astound those early Chinese monks who first packed gunpowder into bamboo tubes. While the basic principles remain unchanged, the execution has become a symphony of precision timing, computer-controlled launches, and increasingly sophisticated chemical formulations. Modern pyrotechnicians work with the same elements that created wonder centuries ago, but they now orchestrate displays with millisecond accuracy, synchronizing thousands of shells to musical scores with a precision that transforms fireworks from simple explosions into choreographed performances. At the heart of today's fireworks industry lies a remarkable tension between preserving traditional methods and embracing revolutionary change. Many manufacturers still rely on hand-rolled shells and time-tested formulations passed down through generations, particularly in regions like Luoyang, China, where fireworks production remains deeply rooted in cultural heritage. Yet these same facilities increasingly incorporate automated production lines, digital quality control systems, and advanced safety protocols that represent quantum leaps from historical practices. The contrast is striking. Ancient wooden mortars stand alongside computer-controlled firing systems, while craftsmen who learned their trade from their grandfathers work alongside engineers, developing next-generation pyrotechnic compositions. Environmental considerations have emerged as one of the most significant drivers of innovation in modern fireworks. The traditional heavy metals that create those brilliant colors, while spectacular, have raised concerns about their impact on air and water quality. This has sparked a renaissance in pyrotechnic chemistry, with researchers exploring organic compounds, biodegradable materials, and alternative chemical pathways to achieve the same visual effects, with reduced environmental impact. Some manufacturers have begun experimenting with nitrogen-rich compounds that burn cleaner, while others investigate plant-based binding agents and water-soluble casings that decompose naturally after use. The quest for more sustainable fireworks has led to fascinating innovations in color chemistry. Scientists are developing new formulations using less toxic alternatives to traditional metal salts, exploring how different molecular structures can produce the same brilliant hues without the environmental persistence of heavy metals. These efforts require delicate balancing acts, as changing one component often affects burn rate, color intensity, or shell performance. The challenge lies in maintaining the visual spectacle that audiences expect while addressing legitimate environmental concerns. Digital technology has revolutionized how fireworks displays are designed and executed. Modern pyrotechnicians use sophisticated software to choreograph shows, creating three-dimensional models that predict exactly where each shell will burst and how colors will interact in the sky. These programs account for wind patterns, launch angles, and timing sequences with mathematical precision, allowing designers to create effects that would have been impossible with manual firing systems. The result is displays that feel more like carefully composed artworks than random explosions, with shells positioned to create depth, movement, and visual narratives across the night sky. The integration of GPS technology and wireless firing systems has enabled displays of unprecedented scale and complexity. Multiple launch sites can be synchronized across vast distances, creating citywide spectacles where fireworks appear to cascade from building to building or move across landscapes in coordinated waves. These systems also enhance safety by allowing operators to maintain safe distances from launch sites while maintaining precise control over timing and sequence. Music synchronization has evolved from a novelty to an essential element of major fireworks displays. Advanced audio analysis software can break down musical compositions note by note, identifying crescendos, rhythmic patterns, and emotional peaks that can be matched with specific pyrotechnic effects. The result is a true multimedia experience where the fireworks don't simply accompany the music, but become visual instruments in a larger orchestral performance. Audiences report feeling more emotionally connected to displays that achieve this synchronization, as the combination of sound and light creates immersive experiences that transcend simple visual spectacle. Safety innovations represent another crucial area of modern development. Traditional fireworks, manufacturing and display involved significant risks, from production accidents to misfires during shows. Contemporary safety systems include remote monitoring of shell conditions, automated safety shutoffs, and sophisticated quality control processes that test each component before assembly. Some manufacturers have developed smart shells, equipped with sensors that can detect problems during flight and self-destruct safely if necessary. These advances have dramatically reduced accident rates while allowing for more ambitious displays. The globalization of the fireworks industry has created interesting dynamics in production and innovation. While China continues to dominate manufacturing, producing roughly 90% of the world's fireworks, innovation often occurs through international collaboration. American and European companies frequently partner with Chinese manufacturers to develop new products, combining Western design concepts with Eastern production expertise. This cross-pollination has accelerated technological advancement while maintaining the cost advantages of traditional manufacturing centers. Customization has emerged as a growing trend, with clients seeking unique displays tailored to specific events or brand identities. Modern manufacturers can create custom colors, develop signature effects, or even embed corporate logos into shell designs. This personalization extends to timing and choreography, where displays are designed around specific venues, audience demographics, or cultural themes. The ability to create truly bespoke fireworks experiences has opened new markets and elevated fireworks from generic entertainment to personalized artistic expression. Training and education in the fireworks industry have also evolved significantly. Traditional apprenticeship models persist, but they're now supplemented by formal educational programs, certification courses, and international exchanges that standardize best practices across borders. Modern pyrotechnicians study not only the chemistry and physics of explosives, but also computer programming, environmental science, and project management. This broader educational foundation has elevated the profession and attracted talent from diverse backgrounds. The economics of modern fireworks production reflect these technological advances. While basic consumer fireworks remain relatively inexpensive, professional displays have become increasingly sophisticated and costly. Major municipal celebrations can involve budgets of hundreds of thousands of dollars, with elaborate shows featuring thousands of shells, complex choreography, and extended duration. This economic reality has professionalized the industry, with companies investing heavily in equipment, training, and research to justify premium pricing for high-end displays. Seasonal patterns in the industry have also shifted with changing cultural practices. While traditional celebrations like New Year's Eve and national holidays remain important, fireworks are increasingly used for private events, corporate celebrations, and entertainment venues. Theme parks, sports stadiums, and cruise ships have become major consumers, creating demand for displays that can be repeated regularly rather than designed as one-time spectacles. This shift has encouraged the development of more durable, reliable systems that can operate consistently across multiple performances. International regulations continue to shape industry development, with different countries maintaining varying standards for safety, environmental impact, and noise levels. These regulatory differences create challenges for global manufacturers, but also drive innovation as companies develop products that can meet diverse requirements. Some manufacturers now produce different formulations of the same effects to comply with various national standards, while others focus on developing universal formulations that meet the strictest global requirements. The amateur fireworks market has experienced its own evolution, with consumer products becoming more sophisticated while maintaining safety standards appropriate for non-professional use. Modern consumer fireworks often feature effects that were once limited to professional displays, albeit at smaller scales and with enhanced safety features. This democratization of pyrotechnic technology has expanded the market while creating new educational challenges as consumers seek to understand proper handling and safety procedures. Research and development in the fireworks industry now extends beyond traditional chemistry into materials science, computer modeling, and environmental engineering. Universities and research institutions increasingly collaborate with manufacturers to explore new possibilities, from biodegradable casings to novel propellant systems. This academic involvement has elevated the scientific rigor applied to fireworks development and attracted researchers who might not traditionally have considered pyrotechnics as a field of study. Quality control has become increasingly sophisticated, with manufacturers employing spectroscopic analysis, high-speed photography, and computer modeling to ensure consistent performance. Modern production facilities often feature clean room environments, automated mixing systems, and rigorous testing protocols that would be familiar to pharmaceutical or aerospace manufacturers. This attention to quality has improved reliability while enabling the complex choreography that defines contemporary displays. The cultural significance of fireworks continues to evolve as well. While maintaining their traditional associations with celebration and national pride, fireworks have also become vehicles for artistic expression, environmental awareness, and technological demonstration. Some displays now incorporate themes related to climate change, social justice, or cultural diversity, using the universal appeal of fireworks to communicate broader messages. This evolution reflects the medium's unique ability to create shared emotional experiences that transcend language and cultural barriers. As we consider the current state of the fireworks industry, we see an art form that has successfully adapted to modern demands while preserving its essential character. The same sense of wonder that captivated ancient Chinese observers continues to delight contemporary audiences, even as the technology has become exponentially more sophisticated. The industry's ability to balance tradition with innovation, spectacle with safety, and local customs with global standards demonstrates the enduring appeal of this ancient art form. Looking at today's fireworks industry, we witness a remarkable transformation that honors the past while embracing the future. The chemistry that began with accidental discoveries in ancient China now powers precisely choreographed displays that can paint entire skylines with color and light. The craft skills passed down through generations work alongside computer algorithms and environmental science to create experiences that are both timelessly magical and thoroughly modern. As the spectacular light of the grand finale fades into memory, let me tell you about the most extraordinary part of the fireworks story, the one that's still being written. The world of fireworks, much like the sparks that dance against the night sky, is evolving in ways that would amaze even the ancient Chinese alchemists who first stumbled upon gunpowder. We're witnessing a renaissance in pyrotechnics, where tradition meets cutting-edge technology, where ancient craftsmanship dances with artificial intelligence, and where the future promises displays more magnificent than anything we've ever imagined. Picture this. You're standing in a field watching what appears to be a traditional fireworks show, but something feels different. The explosions seem perfectly synchronized not just to music, but to your heartbeat. The colors shift and flow like aurora borealis, and the finale creates shapes so intricate they look like digital art painted across the canvas of night. This isn't science fiction. This is the present and future of fireworks, a world where pyrotechnicians have become digital artists and where every shell is programmed with the precision of a computer chip. The transformation began quietly in workshops and laboratories around the world, where innovators started asking a simple question. What if we could control fireworks not just with fuses and timing, but with the same precision we use to land spacecraft or conduct symphony orchestras? The answer has revolutionized everything we thought we knew about pyrotechnics, creating possibilities that would have seemed magical just a few decades ago. At the heart of this revolution lies computerized firing systems, technological marvels that have transformed fireworks displays from approximations into precision instruments. Gone are the days when pyrotechnicians would light fuses by hand, hoping their timing was right and praying the wind wouldn't interfere. Today's firing systems can control thousands of individual fireworks with millisecond accuracy, creating sequences so perfectly timed that they seem to defy the laws of physics. These systems don't just light fireworks. They choreograph them, turning the night sky into a three-dimensional stage where every burst, every color, and every moment of silence is planned with mathematical precision. The technology itself is surprisingly elegant. Each firework is connected to an electronic igniter, a tiny device that replaces the traditional fuse. These igniters are linked to a central computer system that can fire them individually or in complex patterns. The result is mind-boggling precision. Pyrotechnicians can now time explosions down to thousandths of a second, creating effects that were previously impossible. Imagine a waterfall of gold sparks that begins at exactly the moment a violin reaches its crescendo, or a series of red, white, and blue bursts that spell out words, in perfect formation across the sky. But precision is only part of the story. The real magic happens when this technology is combined with music synchronization, creating what many consider the ultimate fusion of visual and auditory art. Modern fireworks shows are choreographed like ballets, with every explosion, every color change, and every moment of darkness carefully matched to the emotional arc of the music. Pyrotechnicians work with sophisticated software that analyzes musical compositions, identifying beats, crescendos, and emotional peaks, then designing fireworks sequences that enhance and amplify these musical moments. The process is surprisingly similar to creating a film score, except instead of violins and trumpets, the instruments are shells filled with stars and special effects. A gentle piano melody might be accompanied by soft silver chrysanthemums that bloom slowly across the sky, while a thunderous orchestral climax explodes in brilliant gold willows that fill the entire horizon. The result is synesthesia made real, music you can see, emotions painted in light and color. Some of the most advanced shows take this concept even further, using real-time analysis to adjust the fireworks based on how the music is actually being performed. Live orchestras naturally vary their tempo and dynamics from performance to performance, and modern firing systems can detect these variations and adjust the pyrotechnics accordingly. It's as if the fireworks are another section of the orchestra, responding and adapting to the musical interpretation in real time. This technological revolution has also democratized the creation of spectacular displays. Computer simulations now allow pyrotechnicians to design and test their shows virtually before a single shell is manufactured. These simulations are so sophisticated that they can model wind patterns, atmospheric conditions, and even the visual perspective from different viewing angles. Designers can experiment with timing, positioning, and effects, creating and refining their displays until they achieve the perfect balance of spectacle and artistry. The software used for these simulations has become increasingly sophisticated, incorporating physics engines that accurately model how fireworks behave in different conditions. Pyrotechnicians can test how a particular shell will perform in various wind speeds, how the smoke from earlier fireworks might affect visibility, and how the curvature of the Earth will impact the viewing experience for audiences at different distances. It's like having a crystal ball that shows exactly how a fireworks display will look before the first fuse is lit. But perhaps the most exciting development is the emergence of interactive fireworks displays. Using smartphone apps and wireless technology, audiences can now become participants in the show, voting on colors, effects, or even triggering certain sequences themselves. Imagine pointing your phone at the sky and watching a burst of your chosen color explode exactly where you're pointing, or participating in a collective countdown where thousands of audience members simultaneously trigger a massive finale. These interactive elements aren't just novelties. They represent a fundamental shift in how we think about fireworks displays. Instead of passive entertainment, they're becoming collaborative experiences where the audience and the pyrotechnicians create something together. Some shows have experimented with biometric feedback, using sensors to monitor the audience's heart rate and excitement levels, then adjusting the display in real time to maximize emotional impact. The technology has also enabled entirely new types of fireworks displays. Drone-integrated shows combine traditional pyrotechnics with swarms of LED-equipped drones that can create moving patterns and shapes in the sky. These hybrid displays blur the line between fireworks and digital art, creating three-dimensional sculptures of light that can move, transform, and interact with traditional fireworks in ways that were previously impossible. Environmental considerations have also driven innovation in remarkable directions. As concerns about air pollution and environmental impact have grown, the fireworks industry has responded with eco-friendly alternatives that maintain the spectacle while reducing the environmental footprint. Biodegradable shells, made from materials like paper and cornstarch, dissolve naturally after use, eliminating the debris that traditional cardboard shells leave behind. New chemical formulations create the same brilliant colors while producing fewer harmful emissions and reducing smoke output. Some manufacturers have gone even further, developing fireworks that actually clean the air as they explode. These shells contain compounds that bind with particulate matter and pollutants, creating a net positive environmental effect. While still in experimental stages, these innovations point toward a future where fireworks displays might actually improve air quality rather than degrade it. Water-based fireworks represent another fascinating frontier. These displays use specialized shells designed to explode over water, creating effects that interact with the surface to produce unique visual phenomena. The combination of light, reflection, and water creates displays that are both more environmentally friendly and visually stunning. Some water shows incorporate underwater lighting and synchronized fountains, creating a multimedia experience that engages multiple senses simultaneously. The globalization of fireworks culture has also accelerated innovation. As displays become increasingly international events, pyrotechnicians from different traditions are sharing techniques and technologies, creating hybrid styles that combine the best elements from various cultures. Chinese precision, Italian artistry, Japanese subtlety, and American spectacle are merging into new forms of expression that transcend cultural boundaries. Training and education have evolved alongside the technology. Modern pyrotechnicians are part artist, part engineer, part computer programmer. They study not just chemistry and physics, but also music theory, color psychology, and digital design. Universities and technical schools now offer specialized programs in pyrotechnic arts, treating fireworks design as a legitimate engineering and artistic discipline. The business side of the industry has transformed as well. Digital design tools and simulation software have made it possible for smaller companies to compete with established giants, democratizing an industry that was once dominated by a few large manufacturers. Independent artists can now design custom displays and work with manufacturers to create unique effects for specific events. Safety technology has advanced dramatically, with new systems that can automatically shut down displays if weather conditions become dangerous, or if unauthorized personnel enter restricted areas. Smart shells can even communicate their status back to the firing system, providing real-time feedback about whether they've functioned properly and alerting operators to any malfunctions. Looking toward the future, the possibilities seem limitless. Researchers are experimenting with fireworks that can create three-dimensional holographic projections, displays that can be seen and heard from space, and even effects that can be synchronized across multiple locations simultaneously. Imagine New Year's celebrations where fireworks displays in different time zones are choreographed together, creating a wave of celebration that follows the sun around the globe. Artificial intelligence is beginning to play a role as well, with systems that can analyze audience reactions in real time and adjust displays accordingly. These AI systems can learn from each performance, gradually improving their ability to create emotionally resonant experiences. Some experimental systems can even compose fireworks, shows automatically, using machine learning to understand what combinations of effects, timing, and music create the most powerful emotional responses. Perhaps most intriguingly, virtual and augmented reality technologies are creating new ways to experience fireworks. VR fireworks shows allow people to experience displays from impossible perspectives, floating among the explosions, seeing them from the inside, or watching from vantage points that would be physically dangerous in real life. Augmented reality systems can overlay digital effects onto real fireworks displays, creating hybrid experiences that exist simultaneously in physical and digital space. The scientific understanding of how fireworks work continues to deepen as well. Advanced spectroscopy and high-speed photography have revealed new details about the chemical and physical processes that create different effects. This deeper understanding is leading to more efficient shell designs, more vivid colors, and entirely new types of effects that weren't possible before. Research into new chemical compounds continues to expand the palette of available colors and effects. Scientists are working on creating true blue fireworks, still the holy grail of pyrotechnic chemistry, as well as effects that can change color multiple times during a single explosion, create specific shapes with remarkable precision, and even produce sounds that are perfectly synchronized with the visual display. The integration of fireworks with other technologies continues to evolve. Some displays now incorporate laser light shows, projection mapping, and synchronized lighting effects on buildings and landmarks. These multimedia spectacles create immersive environments where the entire landscape becomes part of the display. As we stand on the brink of this technological renaissance, it's worth remembering that all of this innovation serves a fundamentally human purpose. Despite all the computers, chemicals, and cutting-edge technology, fireworks remain what they've always been. A way for people to come together and create moments of shared wonder and joy. The technology simply amplifies our ability to create these moments and share them with each other. The future of fireworks isn't just about bigger explosions or brighter colors. It's about creating more meaningful, more sustainable, and more inclusive ways for communities to celebrate together. Whether it's a small-town 4th of July celebration enhanced by smartphone interactivity, or a massive international display coordinated across multiple continents, the goal remains the same: to light up the night sky and, in doing so, light up the human spirit. So the next time you watch fireworks explode overhead, remember that you're witnessing not just an ancient art form, but a cutting-edge technology. You're seeing the culmination of centuries of human ingenuity, from Chinese alchemists seeking immortality, to modern computer programmers choreographing light and sound. And you're glimpsing the future. A future where the boundary between technology and magic continues to blur, where every celebration can be a masterpiece, and where the simple human joy of watching pretty lights in the sky remains as powerful and moving as it was 1,000 years ago. The story of fireworks is far from over. As we gaze up at the night sky and witness those brilliant bursts of light painting patterns across the darkness, we're watching something far more complex than simple explosions. These dazzling displays are the result of centuries of innovation, scientific precision, and cultural evolution, all orchestrated by the ancient marriage of chemistry and physics that transforms humble metal salts into cascading waterfalls of color. By the dawn of the 19th century, fireworks had traveled far from their origins in ancient Chinese courtyards. They had become the crown jewels of royal celebrations, the punctuation marks of national triumphs, and the visual poetry that marked humanity's greatest moments. Yet for all their grandeur, these early displays were painted in a rather limited palette. From the Song dynasty through the Napoleonic era, fireworks bloomed primarily in shades of orange and white, their colors dictated by the natural burn of charcoal and the occasional metallic impurity that might tint the flames. But the 1830s brought a revolution that would transform the night sky forever. Italian pyrotechnicians, those patient alchemists of celebration, made a discovery that seems almost simple in hindsight, yet changed everything. They found that by deliberately adding specific metal salts to their explosive mixtures, they could paint the heavens in virtually any hue imaginable. Strontium salts birthed deep crimsons that seemed to pulse with life. Copper compounds unleashed ethereal blues that rivaled the Mediterranean at twilight. Barium chloride summoned greens as vivid as spring meadows, while sodium painted the darkness in brilliant yellows that seemed to capture sunlight itself. This wasn't merely a technical breakthrough, it was the birth of fireworks as we know them today. The moment when pyrotechnics evolved from simple noisemakers and flamethrowers into genuine artist tools, capable of creating emotional landscapes across the sky. The Italians had unlocked what we now understand as the fundamental chemistry of colored flames. though they couldn't have known the elegant science behind their discovery. What they had stumbled upon was the principle of atomic excitation. But nature abhors such instability, and these energized electrons quickly cascade back to their ground state, releasing their excess energy as photons of light. Each metal produces its own distinctive wavelength, its own signature color, as reliably as a fingerprint. The precision required for these chemical symphonies is remarkable. Modern pyrotechnicians must consider not just which metals to include, but how much of each, how finely they're ground, how they're mixed, and even how pure they are. A trace amount of sodium contamination can wash out other colors with its aggressive yellow glow, while the slightest moisture can prevent proper ignition altogether. It's chemistry practiced at the intersection of art and engineering, where mathematical precision meets creative vision. The physical architecture of modern fireworks reflects this sophisticated understanding. Each aerial shell is essentially a carefully designed chemical factory that must operate flawlessly under extreme conditions. The lift charge, typically black powder, must provide just enough force to propel the shell to its intended altitude without damaging the delicate star compositions inside. The time fuse must burn at a precise rate, accounting for air resistance, wind conditions, and the shell's trajectory to ensure the burst occurs at the perfect moment in its arc. Within the shell, dozens or sometimes hundreds of individual stars are arranged in specific patterns. These stars, each no larger than a marble, contain the metal salts that will produce the colors, bound together with oxidizers like potassium perchlorate and fuels such as charcoal or aluminum powder. The arrangement of these stars determines the shape of the burst. Place them in a sphere and you get a traditional round chrysanthemum. Arrange them in rings and you create concentric circles of color. Pack them asymmetrically and you can make hearts, stars, or even smiley faces bloom across the night sky. The timing of color changes within a single firework represents another level of sophistication. By layering different chemical compositions within each star, pyrotechnicians can create effects that shift from one color to another as they burn. A single star might begin life glowing red from strontium, transition to white as magnesium takes over, and finish with a tail of golden sparks from iron filings. These transformations happen over mere seconds, but they require precise understanding of burn rates, chemical compatibility, and thermal dynamics. Perhaps most remarkably, modern fireworks can achieve effects that seem to defy the basic principles of chemistry. Blue remains the most challenging color to produce consistently, requiring copper compounds that are notoriously unstable and temperature sensitive. Purple, being a mixture of red and blue, compounds this difficulty. Yet skilled pyrotechnicians have developed techniques using specific chlorine donors and carefully controlled burn temperatures to coax these stubborn hues from their chemical components. The sounds of fireworks, too, have evolved far beyond simple bangs. Titanium powder creates the brilliant white flashes and sharp reports of salutes. Aluminum and iron create different tonal qualities in the explosions. Some compositions include layers that burn at different rates, creating the distinctive whistle of rising shells or the crackling effect of willow patterns. Even the timing between visual and auditory effects is carefully orchestrated, accounting for the speed of sound to ensure the visual and sonic elements arrive at the audience in perfect harmony. Modern displays push these chemical and physical principles to their absolute limits. Computer-controlled firing systems can synchronize thousands of shells to create seamless walls of color that paint and repaint the sky dozens of times per minute. GPS timing ensures that multiple launch sites, sometimes miles apart, can coordinate their effects to the millisecond. Digital choreography allows pyrotechnicians to design shows that respond to music, creating genuine multimedia experiences where chemistry, physics, and art converge in real time. The environmental considerations of modern pyrotechnics have also driven innovation in directions the Italian pioneers never could have imagined. Biodegradable shell casings, made from paper or cardboard, have replaced plastic components. Low smoke compositions reduce air pollution without sacrificing visual impact. Some manufacturers are experimenting with nitrogen-based propellants that could eliminate the need for traditional black powder entirely, though such innovations remain largely experimental. The globalization of fireworks manufacturing has created interesting cultural fusions in pyrotechnic design. Chinese manufacturers, building on their millennium-old heritage, have industrialized the production process while maintaining traditional quality standards. Italian artisans continue to handcraft specialty shells for high-end displays, often incorporating techniques passed down through generations of fireworks families. Japanese fireworks artists have elevated the craft to an almost spiritual level, creating shells that bloom with geometric precision and fade with mathematical elegance. The science behind these displays continues to evolve. Researchers are experimenting with nanotechnology to create more efficient color producers, with some metal nanoparticles requiring far less material to achieve the same visual impact. Computer modeling allows pyrotechnicians to test shell designs virtually before committing to expensive physical prototypes. High-speed photography and spectrographic analysis help manufacturers fine-tune their formulations with unprecedented precision. Yet for all the technological sophistication, the fundamental appeal of fireworks remains beautifully simple. They transform the most basic human impulse, the desire to create light in darkness, into something transcendent. Each burst represents a moment when chemistry becomes visible, when the invisible forces that govern atomic behavior paint themselves across the sky in colors that exist nowhere else in nature. As you watch the next fireworks display, whether it's celebrating a national holiday, a wedding, or simply the joy of a summer evening, remember that you're witnessing one of humanity's most elegant collaborations between science and art. Those fleeting moments of color and light represent centuries of accumulated knowledge, from ancient Chinese alchemists to modern chemical engineers, all working to create something that serves no practical purpose except to fill us with wonder. The chemistry may be complex, the physics demanding, and the engineering precise, but the result is pure magic. In an age where we often feel disconnected from the natural world, fireworks remind us that science itself can be a source of beauty, that understanding how something works doesn't diminish its capacity to inspire awe. Now we arrive at something magical, something that transforms mere sparks of light into a cosmic celebration. The story of fireworks isn't just about chemistry and physics, though those are crucial ingredients. It's about how human beings, through centuries of careful observation and experimentation, learn to paint the night sky with color. It's about how we discovered that by mixing just the right elements, heating them to precise temperatures, and timing their release with mathematical precision, we could create something that speaks to the deepest part of the human spirit. The colors that dance across the dark canvas above us each tell their own chemical story. Red blooms from strontium compounds, their electrons jumping between energy levels in a cosmic dance that releases photons at just the right wavelength to trigger the cone cells in our retinas. When strontium carbonate or strontium nitrate burns in the heart of a firework shell, it doesn't just create light, it creates memory. The deep crimson that spreads across the sky carries with it the warmth of celebration, the richness of tradition, the boldness of festivity. Orange emerges from the marriage of calcium and sodium compounds, a gentle fusion that creates flames the color of autumn leaves and sunset horizons. Calcium chloride burns with a steady, reliable glow, while sodium adds its brilliant yellow undertones. Together, they paint the sky with the hues of harvest moons and flickering candlelight, colors that feel both ancient and eternal. Yellow springs forth from sodium compounds in their purest form. Sodium carbonate and sodium oxalate, releasing their characteristic golden light. It's the color of sunshine captured and released, of warmth and joy, and the simple pleasure of brightness against darkness. When sodium burns, it does so with such intensity that even tiny amounts can overwhelm other colors, which is why pyrotechnicians must handle it with the delicacy of a watercolor artist, knowing that a single misplaced grain can turn a carefully planned rainbow into a wash of gold. Green, that most challenging of firework colors, comes from barium compounds, particularly barium chloride and barium carbonate. The chemistry of green is finicky, requiring precise temperatures and careful atmospheric control. Too hot, and the green fades to white. Too cool, and it barely glimmers. But when conditions are perfect, barium burns with the ethereal glow of spring leaves, of deep forest canopies, of life itself reaching toward the light. Blue, the most elusive color in the pyrotechnician's palette, emerges reluctantly from copper compounds. Copper chloride, when heated in just the right environment, releases photons at the wavelength we perceive as blue. But blue is temperamental, demanding specific temperatures, precise atmospheric conditions, and the absence of contaminating elements. It's a color that must be coaxed rather than commanded, which is perhaps why a perfect blue firework feels like such a gift when it finally blooms across the night sky. Purple requires the marriage of two difficult colors, the red of strontium dancing with the blue of copper in a delicate balance that can shift with the slightest change in temperature or composition. It's a color that exists at the edge of possibility, reminding us that some of the most beautiful things in life require the most careful attention. White comes from the burning of magnesium or aluminum, metals that burn with such fierce intensity that they release light across the entire visible spectrum. These are the stars that shower down like celestial confetti, the bright points of light that punctuate the colored blooms with exclamation marks of pure radiance. But color is only one dimension of the fireworks' artistry. The shapes that unfold above us, the chrysanthemums and willows, the rings and hearts, and cascading waterfalls of light. These are created through the careful arrangement of stars within the shell. Each star is a small pellet of pyrotechnic composition, precisely sized and positioned to create specific effects. When the bursting charge explodes at the shell's heart, it sends these stars flying outward in predetermined patterns, each one trailing its own colored flame as it arcs through the darkness. The timing of these effects is controlled by delay fuses, thin threads of slow-burning composition that carry fire from one element to another with clockwork precision. A multi-break shell might have several layers of stars, each separated by its own delay charge, creating a sequence of blooms that unfold like a flower opening in slow motion. First a burst of gold, then after a perfectly timed pause, a shower of blue and silver, followed by a final cascade of red and green that fades slowly into the night. The sounds that accompany these visual symphonies are no accident either. The sharp crack of a report charge, the whistle of a rising shell, the gentle pop of stars igniting. All of these are carefully orchestrated elements of the performance. Titanium powder creates the brilliant white flashes and sharp reports that punctuate the display. Potassium benzoate burns with a characteristic whistle as gases escape through carefully designed channels. Even the timing of silence becomes part of the composition. Moments of quiet that allow the echoes to fade and anticipation to build before the next crescendo. Modern fireworks have evolved far beyond the simple rockets and Roman candles of earlier centuries. Computer-controlled firing systems now allow pyrotechnicians to synchronize displays with music, creating performances where every burst, every color change, every moment of silence aligns with the rhythm and melody of accompanying soundtracks. These systems can fire shells with millisecond precision, creating effects that would be impossible to achieve by hand-lighting individual fuses. The shells themselves have become marvels of engineering. Multi-break shells contain several separate charges, each timed to explode at different altitudes, creating layered effects that build and evolve as they fall. Crescent shells break into several smaller shells, each of which explodes separately, filling the sky with a constellation of smaller bursts. Ring shells create perfect circles of colored stars, while heart shells and star shells form recognizable shapes that seem to hang in the air for magical moments before fading away. Some of the most spectacular effects come from shells that change color as they burn. These use stars with multiple layers of different compositions, creating blooms that shift from gold to red to green as each layer ignites in sequence. The effect is like watching a flower change its petals in real time, a transformation that speaks to something deep in our aesthetic sense. As we stand beneath these displays, watching colors bloom and fade against the velvet darkness, we're witnessing the culmination of centuries of human curiosity and creativity. From the accidental discovery of gunpowder by ancient Chinese alchemists to the precise computer-controlled displays of today, fireworks represent humanity's ongoing desire to transform the ordinary into the extraordinary, to take the basic elements of the earth and turn them into something that lifts our spirits and reminds us of the beauty that's possible when science and art work hand in hand. Each burst of color above us carries within it the echoes of all the fireworks that came before, all the celebrations and commemorations, all the moments of joy and wonder that humans have marked with light and color and the gentle thunder of controlled explosions. In the end, fireworks are more than just chemistry and physics. So we're finally here, at the end of our gentle journey through the ticking tapestry of time. And hopefully you've found this exploration both soothing and illuminating. Throughout our sleepy voyage, we've discovered that time isn't just the steady tick of a clock, but a deeply personal experience shaped by memory, attention, and the very structure of the universe itself. From ancient sundials to atomic precision, from Einstein's revelations to the quantum mysteries that still puzzle us today, we've seen how this most fundamental aspect of existence continues to flow forward, carrying us all along in its patient, eternal rhythm.